watching them fly off up into the sky, there seems no limit to how high a helium balloon can go. In reality, there are two major constraints: the strength of the balloon material and the Archimedes principle. As the balloon ascends, the pressure of the surrounding air drops, while the helium inside expands. Toy balloons burst at around 10 kilometers, while professional meteorological balloons reach heights of 30 kilometers. Welcome to GNP Animations. In this video, we are going to see how helium gas is made. On Earth, helium, officially called helium-4, comes from radioactive decay. When a radioactive element like uranium or thorium breaks down over time or decays, it will occasionally lose 2 protons and 2 neutrons. They will just break off. This is called alpha decay. If that alpha particle grabs a couple of electrons, it forms helium-4. Helium is usually produced as a byproduct of natural gas processing. Natural gas contains methane and other hydrocarbons, which are principal source of heat energy when natural gas is burned. Most natural gas deposits also contain smaller quantities of nitrogen, water vapor, carbon dioxide, helium, and other non-combustible materials. When the gas contains more than about 0.4% helium by volume, a cryogenic distillation method is often used in order to recover the helium content. In this video, we are going to see 3 parts and 10 steps of making helium gas. Part 1 is pre-treating. Because this method utilizes an extremely cold cryogenic section as a part of the process, all impurities that might solidify, such as water vapor, carbon dioxide, and certain heavy hydrocarbons, must first be removed from the natural gas in a pre-treatment process. Step 1. Removing carbon dioxide. The natural gas is pressurized to about 800 psi. It then flows into a scrubber, where it is subjected to a spray of monoethylamine, which absorbs the carbon dioxide and carries it away. Step 2. Removing water molecules. The gas stream passes through a molecular sieve, which strips the larger water vapor molecules from the stream while letting the smaller gas molecules pass. The water is back flushed out of the sieve and removed. Step 3. Removing heavy hydrocarbons. Any heavy hydrocarbons in the gas stream are collected on the surface of a bed of activated carbon as the gas passes through it. The gas stream now contains mostly methane and nitrogen with smaller amounts of helium, hydrogen, and neon. Part 2 is separating. Natural gas is separated into its major components through a distillation process known as fractional distillation. In this process, the nitrogen and methane are separated in 2 stages, leaving a mixture of gas containing the high percentage of helium. The gas stream passes through one side of a plate fin heat exchanger, while very cold methane and nitrogen from the cryogenic section passes through the other side. The incoming gas stream is cooled while the methane and nitrogen are warmed. Step 4. The gas stream then passes through an expansion valve, which allows the gas to expand rapidly while the pressure drops to about 145 to 360 psi. This rapid expansion cools the gas stream to the point where the methane starts to liquefy. Step 5. The gas stream, now part liquid and part gas, enters the base of the high pressure fractionating column. As the gas works its way up through the internal baffles in the column, it loses additional heat. The methane continues to liquefy, forming a methane-rich mixture in the bottom of the column, where most of the nitrogen and other gases flow to the top. Step 6. The liquid methane mixture, called crude methane, is drawn out of the bottom of the high pressure column and it is cooled further in the crude subcooler. Then it passes through a second expansion valve, which drops the pressure to about 22 psi before it enters to low pressure fractionating column. As the liquid methane works its way down to the column, most of the remaining nitrogen is separated, leaving a liquid that is no more than 4% nitrogen and remaining methane. This liquid is pumped off, warmed, and evaporated to become upgraded natural gas. Step 7. Meanwhile, the gases from the top of the high pressure column are cooled in a condenser. Much of the nitrogen condenses into a vapor and is fed into the top of the low pressure column. The remaining gas is called crude helium. It contains approximately 50 to 70% helium, 1 to 3% unliquefied methane, smaller quantities of hydrogen and neon, and the remaining nitrogen. Part 3 is purifying. Crude helium must be further purified to remove most of the other materials. This is usually a multi-stage process involving several different separation methods. Step 8. The crude helium is first cooled to about -193 degrees centigrade. At this temperature, most of the nitrogen and methane condenses into a liquid and they are drained off. The remaining gas mixture is now 90% pure helium. Step 9. Air is added to the gas mixture to provide oxygen. The gas is warmed in a preheater and then it passes over a catalyst which causes most of the hydrogen in the mixture to react with the oxygen in the air and forms water vapor. The gas is then cooled and the water vapor condenses and is drained off. Step number 10. The gas mixture enters a pressure swing absorption unit consisting of several absorption vessels operating in parallel. Within each vessel, there are thousands of particles filled with tiny pores. As the gas mixture passes through these particles under pressure, certain gases are trapped within the particle pores. The pressure is then decreased and the flow of the gas is reversed towards the trapped gases. This method removes most of the remaining water vapor, nitrogen and methane from the gas mixture. The helium is now about 99.99% pure. And this is how helium is made. Subscribe to GNP Animations for more videos.